Hi, computer scientists. Mr. Stafford here. And today I wanted to talk to you about encryption, decryption, and why we need these tools when using the internet. So one thing to keep in mind when using the internet is that it's an open and public system, meaning that anyone with internet connectivity can use this tool, but also anyone and everyone can see traffic that's happening over the network. And so one of the things to keep in mind is that we need to keep our data secure. One of the things that I want to show you is a tool called Wireshark. Now what Wireshark is it enables you to see different protocols that are happening on your network and traffic that's happening over the network. So this is a tool that we can use to look at traffic, but also when used in nefarious ways, people can use it to see private information. So we don't want to do that, but we also want to be able to protect ourselves and see when things like this are happening. So if I run Wireshark and I go over to this website that's a login test, and it's we can see that this site is not secure. So if I enter in a username, say user1234, and then I enter my password, I'm going to show you in just a second that we can determine what my password is without seeing it here, but using that tool of Wireshark. Okay, when I click login, we'll see it says, sorry, but the username that you entered does not exist. Okay, and then I'm going to come back to Wireshark and hit stop. So one of the protocols that's used over the internet is called TCP, Transmission Control Protocol. And I want to see if TCP contains username. Now I typed in username and I can see that my transmission control protocol picked up traffic that contained this word username, and we can see that the info was posted. So looking at the traffic down here, a lot of it is kind of garbage data, but I can continue to flow down until I see something of interest, and I'm seeing something right here. Now it says username user1234, and you saw me type that in. But then I'm seeing txt, which is the text of my password, and we're seeing that my password was PASSWORD12345, and that's what I typed in. So what we need to do is, number one, when using websites, make sure that it is secure. This was insecure, which is not good to use. So do make sure that if you are putting in any information into a site, that you're using a secure site. Okay, and I'm going to quit without saving. And we're going to take a look at some of the most basic encryption algorithms. One of the most basic encryption algorithms is the Caesar cipher. And I'm going to show you some tools that I use in my classroom from code.org. And what the Caesar cipher is we call it an alphabetical shift. And I have a message right here, and I want to see if that we can crack the following secret message. And it is this. So I'm going to copy this text, okay? And I want to determine what this message is when I go into the Caesar cipher. So I'm going to write my own message here. And I'm going to click add. Now, if I don't shift this alphabet, this message doesn't really make a lot of sense. But when I shift the alphabet, meaning if now I'm shifting, A maps to Z, B maps to A, C maps to B, D maps to C, I look over here and this is recognizable to me. I just shifted it once and it says I heart CS. Okay, now let's do something a little bit more interesting. I'm going to go back, and this is more of a challenge for me. So I'm going to go ahead and grab this text, go back and paste it into my Caesar Cipher widget, and click Add. Now, even with the shift of 1, when I shifted the alphabet one time, this is still a mess. And I'm going to go back to the original where A maps to A, B maps to B. Okay, I can't determine what that says. So I'm going to continually shift this alphabet until it looks like something that I can read. So I've shifted it 6 times, 7 times, 8 times, 9, 10, 11, 12, 13. Okay, so I've shifted the alphabet 13 letters. So now A is mapping to N, B is mapping to O. And when I zoom in, I see free pizza in the cafeteria. Okay, so that's the Caesar cipher. Now, that's not a very robust encryption algorithm. There's only 26 letters in the English alphabet. So at most, I'm going to have to shift the alphabet 26 times to determine what it's going to say. So let's take a look at another type of encryption algorithm. Okay, but just to recap again, encryption is a process of encoding a plain text message in a secret way. Decryption is the process of reversing that encryption, taking a secret message and reproducing the original plain text. And that's what we did with that Caesar cipher widget, is we decrypted it. Now a cipher is just a generic term for the technique or algorithm that performs the encryption. Okay? And now what we're going to take a look at is the random substitution cipher. Now what a random substitution cipher is every letter in the alphabet is going to be mapped to a different letter. So not every single letter is shifted the same amount. Now let's go ahead and take a look at the random substitution cipher widget from code.org. What we have here is a plain text message. Nothing has been changed. And we're seeing that A will map to A, B will map to B, and C will map to C. Okay? And when I assign this, nothing will change because I haven't manipulated any of these letters to be different. So I'm going to go ahead and reset that, and I'm going to show you how we can do this, the random substitution. Let's say I want to map A with N and N with A. So if I assign this, right, I've only assigned A with N and N with A, and I'm seeing that here is N, P-L-N-I-A, text mess N-G-E. So everywhere that there was an A is now replaced with an N and vice versa. So I'm going to reset what I have. And what we can also take a look at are these by percentages. So let's take a look at what that by percentage actually is. Now, we have this concept of frequency analysis. And what frequency analysis is looking at the frequency of occurrences that letters appear in an encoded message. And one can infer possible solutions due to the common frequency of character use. Here's what that means. In the English language, some characters are used more often than not. So down here where I'm going to use the substitutions, I can arrange these by percent. Now, E is the most commonly used letter in the English language, followed by T and then A, all the way down to Z, which is the most infrequent letter used in the English language. And that's not to say that every single message aligns with the frequency of letters used in the English language, but you can get kind of close. So in this message, this message that says, here's a plain text message that hasn't been encrypted at all, I can arrange it by its frequency of letters also, right? And we see that it doesn't exactly match all the way up. T is the most frequently used letter in the message, where E is the most frequently used letter in the English language. And even though these letters are pretty close to matching up, if we assign the frequency letters with our originals, we're going to see that it still doesn't make any sense. So it's not that close for me to be able to tell what this message says. So we got to think about some strategies if I were to decrypt this message, how I would do that. So I'm going to reset this, and let's take a look at a message that we don't know what it says yet. So this message has been encrypted with this random substitution cipher, and to get a good start again, what I want to do is assign my original text 5%. So we're getting the frequency to line up as close as we can and then try to assign new letters to them. So I'm going to go ahead and assign these letters. So for example, if I take a look at the first word that says NPD, and I look at N in the original message and I find N is going to get assigned a Y. And if I look at P, and I find P here, P is going to get assigned A. So this NPD, I'm going to assign it, and this says YAH. So we have to think of some other strategies to determine what this message says. So one of the strategies is just looking at these words and trying to determine, like, okay, what might this word be? So YAHOGTNITSE. Here's what I'm thinking. This TSE, it might be, okay, a common three-letter word. And one of the most common three-letter words that I can think of that start with a T and end with an E is the word the. So this S needs to change. So what I need to do is find S and change it with an H. So now I'm going to swap it, and it did say TSE, but now it says the. And I see another word over here that says the, and this is the. So we're going to repeat that process by trying to determine if there's any other words that we see. So the first 1, 2, 3 words I don't really know what I want to change it to yet. I've got the. This doesn't make any sense. But then I look at this word, BAWKCATESR. Now that, to me, looks pretty close to something. So BAWK. Now I'm going to change that W to a C just because I want to spell the word back. So I'm going to find W and change it with a C. And now this says backwatesser. That to me looks like backwaters. So I'm going to change this S and the R around, and looking over here, we see the S and the R are really close anyway in frequency. So I'm going to change that. So this says the something, backwaters, something, the. And then I'm going to look at this two-letter word. There's only a handful of two-letter words that I can think of off the top of my head, like in or on. So I'm going to change this NI, I'm going to change it to the word in. So N needs to be I, and I needs to be N. And again, looking at the frequencies here, I and N are very close. So I'm going to change those. And it says in the something else. And let's take a look at that. GN chartle. Well, how about in the, using some Wordle skills, this to me kind of looks like uncharted. So uncharted. So if I change this G to a U, so I need to find G and change this G to a U. And if I find U, changing the G to a U, and I click and I drag it over, let's see what the message says now. Yar out in the unchartle. Now L, I want that to be a D. And again, L and D are pretty close with frequency. So we'll flip those around. Ooh, I've done something wrong. Now S should be D. And I'm going to change that S with that L again. I think I went too far with it. So yar out in the uncharted backwaters. I think that Y is an F. So far out in the uncharted backwaters. And again, I want to change that Y to an F. Of the, so let's change that Y to an F. So I need to find the Y and change it to an F. So we can see, I'm gonna end this right here. It says, far out in the uncharted backwaters of the unfashionable end of the western spiral, not sure what that is, but we could be here for a while and decipher this. And we got pretty close. So it took me a little bit longer than the Caesar cipher. So the random substitution cipher is a little bit more complex. And as a human, it takes me a while to do this, but computers can do this a lot faster. So I'm going to show you one more cipher, or one more encryption technique that's called the Vigenère cipher, okay? And what the Vigenère cipher is, it's a cipher method of encryption, of encrypting alphabetical text by using a series of interwoven Caesar ciphers based on the letters of a keyword. So now what we're going to do is introduce a keyword. So we'll see if we can kind of follow along with this. So here is the Vigenère cipher. So it says, enter your text message. And I've got 140 characters to play with. So it says, if only this message could be a secret. And now we've got a secret key that we have entered, okay? And I'll play this in just a second, but here's the result. What we're doing is we're taking the key and we're taking our plain text and we're creating a ciphertext. We are encrypting it with this Vigenère cipher. So let's kind of determine, let me show you how we determine what the ciphertext is going to be. So my key, which we have as my underscore secret key, starts with an M. Now in the vertical column, I have this M, and in my plain text says, if only this message could be a secret. And it starts with an I. So what happens is, we set this grid up to map our alphabet with our key and our plain text. So wherever my key and my plain text line up is the letter that I am going to write for my ciphertext. So I see that M and I align with U. Now, then I'm going to go ahead and hit play and stop. Now my key has a Y and an F, and Y and F align to be a C, and so it is now part of my ciphertext. Another character that we can put into the Vigenère cipher is this underscore, An underscore is a character. So where this character of underscore lines up, and I see that in the plain text it's also an underscore, we're going to hit play and see where they line up. Now the underscore and the underscore both line up at Z. Now we'll let this thing run out. And we can see how this works is it's going to continually run until I reach the end of my secret key. And this is where I want to stop. Now, my key is my secret key, and the plain text is if only this message could be a secret. But what happens when I reach the end of the key? Well, I just loop back and continue from the beginning of my key. So when I play this, I'll stop it again, and my plain text continues on, but my key is being repeated. So now I continue to run this. And I continue to use that secret key until I am finished encrypting my plain text message. And now that it's finished, we can see that my plain text was if only this message could be a secret, and I would say that this is now a secret to take care of. So what I want you to think about is what secret keys would be good for the Vigenère cipher, and what secret keys would be bad for this Vigenère cipher. And what I want to show you is one of these secret keys that may not be very good. Let's say that my secret key is just E. And I want to reset and run this, and we'll go at a faster pace. And if we're looking and seeing what happens, if my secret key is just E, we notice that this never changed up and down for the vertical column. And so all that is doing, all that's happening, is that we are mapping it to a single change in letter, which is exactly like the Caesar cipher. So if my secret key, if I change my secret key to A, and I reset and I run this, that's not going to shift anything. We see that Caesar cipher is just mapping the same letter to itself. So my plain text is if only the message could be a secret, and the cipher text is if only this message could be a secret. So when picking a key for the Vigenère cipher, one that would be good is a lot of complexity in it, using a sentence. So this, if I want to use this underscore, could be a very good key. I have a lot of different letters used in it. It's longer, and we can see that it's a lot more random than just using a single letter. So to kind of recap what we've just done from beginning to end is that we understand that we need encryption over the internet, because if we don't, we can see plain text messages being sent across these protocols. And we've taken a look at a couple of different encryption algorithms that we can do as humans. The first one was the Caesar cipher, the second one was the random substitution cipher, and the last one is the Vigenère cipher. Now there's a lot more complex encryption algorithms used today. These are not used over the internet, but it's the same general concept. We take a regular text message and we scramble it up so that it takes an unreasonable amount of time for a computer to decrypt it so that our information stays safe and stays encrypted.